Hello students, welcome to this 22nd lecture session of Database Management Systems course. In this session, we will discuss various concepts related to database security. We understand what is the significance of database security, what do we mean by it, what are the various threats to databases, and the control measures we need to take, database security and the role of the database administrator in maintaining the security, discretionary access control mechanisms and mandatory access control mechanisms. Then we look at the statistical database security issues, flow control, the role of encryption, and the various challenges that are faced in database security. And we already understood what is the significance of databases in the present day IT world, and every business, every organization uses its databases for some purpose, directly or indirectly, and it is treated to be a significant component or wealth of a business or the organization. Most databases today provide access that span several networks and across the world. And nowadays, not just the local databases, and many of the systems and applications, they try to access the data that is stored at different locations over the network. It is not just local data storage and then retrieval concept. Society now heavily relies on technology. We understand that. Advancements in the technology have enabled us to use network databases to preserve the most critical infrastructures like the water, oil, gas, electricity grids, and power plants, so on and so forth. And all these applications which manage, which control these grids and then other power supply grids and then the power generation plants and so many other infrastructures, they actually heavily rely on the databases. Any breach to these may cause huge loss of money and then livelihood and even sometimes the life as well. That's why security has become a very significant aspect. The progress in technology has attracted an exponentially growing number of network and then database users that we already understood. Nowadays, a large quantum of personal and then business critical data is available through public networks. This situation has attracted intruders seeking destruction and monetary gain. Database security has become an issue of global importance. As networks become more sophisticated, so do intruders. And it is a race between the network security team or database security team and the intruders who try to gain access with mal intentions. Though 100% security cannot be achieved, we need to make every effort to minimize the risk and stay one step ahead of the intruders. That is the major objective. Now let us look at a definition of database security. Database security is a set of established procedures, standards, policies, and tools that is used to protect data from theft, misuse, unwanted intrusion, unwanted activities, and attacks. Now let us look at more details about the database security. Database security is a broader area that addresses many issues, including the following, what I mentioned here: legal and then ethical issues regarding the right to access certain information, policy issues at the governmental, institutional, or corporate level as to specify what kind of information should not be made publicly available, and system related issues, whether the security function should be handled at the physical hardware level or at the operating system level or at the database management system level. The need in some organizations to identify multiple security levels and to categorize the data and users based on these classifications. These are the major issues in database security. Now let us look at the threats to databases. The key achieve Sorry, I repeat. The key to achieve an effective data security architecture relies on an organization's efforts to maintain the confidentiality, integrity, and availability. These three are the very, very important goals. What do we mean by confidentiality? It deals with protection of data from unauthorized disclosure. Integrity means protection of data from improper modifications by malicious users. Availability means making database objects like relations, schemas, tuples available to users or programs to which they have a legitimate right. These are the major goals. These terms are commonly known as CIA model for security. Threats to databases result in compromising with some or all of the above mentioned goals. It is customary to refer to two types of security mechanisms. The first one is discretionary security mechanisms, which are used to grant privileges or rights to users, including capability to access specific data files, records, or fields in specific mode, that is read, insert, delete, or update. The second mechanism is known as mandatory security mechanism, where it is used to enforce multi-level security by classifying the data and users into various security classes or levels, and implementing the appropriate security policy of the organization on these levels. Now let us look at control measures. There are four main control measures that are used to provide security of data in databases. Access control, that is restriction to database system as a whole, that is we restrict users or the persons from accessing the database as a whole. This can be done by creating user accounts. If a user doesn't have an account, then a person doesn't have an account, he cannot access the database. That is restricting users or the persons to database systems, access to database systems as a whole. Next, inference control. In statistical databases, where we store the statistics related to the huge demography, and we should provide only summary of the data without permitting the users to access individual data. That is, suppose if you take the example of storing data pertaining to the health related records of users, or the income related data, so on and so forth. So for huge masses, that is a large population, we store this kind of data, and then it is essential to maintain the confidentiality. That is, the data pertaining to one person should not be disclosed to others. Sometimes it is these kind of databases are known as statistical databases because they store the statistics related to a huge population on a particular subject. Sometimes it is possible to deduce information by carefully querying the summary data. Of course, let us not put too much focus on this point at this point of time, and maybe in the second component of this PPT or the session, we are going to elaborate on this statistical databases. Next is flow control, which prevents the information from flowing in such a way that it reaches unauthorized users. Such channels which violate the security policies and flow and allows or makes the flow of information to unauthorized users is known as the covert channels. And the last one is data encryption, which is used to protect data when it is being communicated over the network. Database security and the role of the database administrator. We understand that database administrator is the central authority for managing the databases. He is responsible for classifying the users and data, granting and then revoking permissions in accordance with the policy of the organization. The database administrator account is the super account. That means he can perform any activity on the database. The DBA privileged commands permit him to perform the following. He can grant privileges. He can, first of all, he can create new accounts for the users, and he can grant privileges on the accounts, and as and when required, he can also revoke, that is take them back. Okay, the privileges that have been granted to the users can be revoked by the database administrator. And let us look at the mechanism database security. Sorry, I repeat. Let us have a look at the security mechanism, which we call it as discretionary access control mechanism. The typical method of enforcing discretionary access control in database systems is based on the granting and revoking of privileges. The set of commands which are known as the data control language commands, which are part of SQL, can be used or used for this purpose. And any implementation of SQL for many database management systems, they support DCL, data control language commands, using which you can create accounts, you can grant permissions on various operations on various objects like relations, schemas, or the records or fields of a given relation, so on and so forth. And as and when required, we can also take them back. That means we can revoke the rights granted on users. That is, the privileges can be granted at account level, specifying the privileges to accounts. Create schema, and when you create a user account, and I can say that I can permit him to create schemas, permit the user to create tables, permit him to create views, alter the schemas, alter the tables, modify and select the relations, tuples from the relations, etc. And the privileges can be granted at relation level. Okay, that is, the privileges can be granted at different levels of granularity. I can do it at the account level or user level, or I can also do it at the individual relations level. Controlling privileges to access to specific tables. Select privilege on or, that means I can grant select privilege to some user on a given relation. I can also grant the modify privilege on a given relation to a given user, so on and so forth. For example, if you take this, grant select on employee table to user 1. That means the administrator is granting select privilege wherein the user 1 can perform select operation on employee table. And once this is given, the user is capable of performing that operation on the given object, that is employee table, and the DBA can revoke at any point of time, depending on the need. The DBA can revoke the select privilege granted to user 1 on the employee table. It is possible. Similarly, propagation of privileges using grant option are also possible. You see here, grant create tab to A1. That is, the database administrator has granted create tab operation, that is privilege to user A1. Next, create schema company authorization to A1. Now, A1 creates a table called as T1, that is, A1 is the user. If he creates a table T1, he is the owner of the table T1 and he can grant permissions to others because he is the owner of that particular database object, that is T1, which is a table. Now, A1 can say that grant privileges to perform insert and delete operations on T1 because he is the owner of that particular table to other user A2. Now, A2 can perform insert and delete operations on T1. And if A1, that is user A1, wants to give the grant option to A2, wherein once this option or privilege is given to A2, the A2 is capable of granting privileges to other users. Let us have a look at the example. Grant, now A1 is executing this command, grant select on T1 because A1, user A1 is the owner to A3. He is granting privilege on select operation to user A3 with grant option. Once this grant option is given or propagated to A3 by A1, who is the owner of the table T1, now A3 can grant select privilege to others. And this grant option is propagated or given to A3 on only one operation, that is select operation. He cannot grant permission to any other user on any other operation. Now, A3 can grant permission to select on this table T1 to any other user. Now, as and when required, A1, who is the owner of the table T1, since he has granted privileges to A3 with grant option, he can revoke that privilege. Revoke, select on T1 from A3. So automatically from then onwards A3 cannot perform select option, and at the same time the privileges that have been propagated to other users through A3 will also come to SCs. Okay. Grant update on EMP SAL to A3. Since A1 is the owner of the table, if we assume that if the A1 is the owner of the table EMP, he can invoke this, or he can grant this permission. Grant update on EMP table on specific attribute, that is only on the salary attribute of EMP table to A2. From now onwards, the A2 can perform update operations on employee table on a given specified attribute, that is SAL. He cannot update any other attribute values. He can only perform update on the salary attribute of employee table. And as and when required, A1 can revoke the grant update permission given to A2. We have seen discretionary access control. Now let us have a look at the mandatory access control mechanism. In many applications, an additional security policy is needed that classifies the data and users based on security classes. This approach is known as the mandatory access control mechanism. That means we have the subjects or the users or applications who use the data contained in the database are known as the subject, and the objects, that is the database objects. It could be a schema, it could be a table, it could be a relation or a particular attribute which is part of the relation. All these things become what? The objects. Now in this mandatory access control security mechanism, we classify the subjects and objects. We classify the users and the data objects into classes, and the very typical security classes are the top security class, very high security class TS, and then abbreviated as TS. Next class is the secret, which is abbreviated as S. Next is confidential, C, and the unclassified denoted by U. And then this is the lowest security class in this model. In one of the common model, which is known as Bell-LaPadula model, we have subjects and objects. I already mentioned about this in the previous example. And subjects means the users or the user accounts or the programs which try to access the data items. Objects means the relations, tuples, columns, views, operations that are performed on the objects. According to this, a subject S is not allowed to read access to an object O unless the class of the subject is greater than or equal to class of the object. This is known as simple security property. And the second property is known as the star property, which defines that a subject S is not allowed to write an object O unless the class of the subject is less than or equal to the class of O. Okay, and these two are the properties are part of the Bell-LaPadula model, where we divide the data objects and the users into classes. We call them as, the users are called as subjects, and then the data items or objects are known as the objects. Okay, let us have a look at the example. Okay, in this example we have subjects and then we have objects, and according to this model, we have top secret class, secret class, confidential class, unclassified class. Okay, and let us have a look at the objects. For instance, we have taken budget table, performance document, promotions list table, transfers table, work allotment table, employee table, department table. Budget table and then performance table, they are classified as top secret. Promotions and transfers, they are classified as secret. Work allotment is classified as confidential. Employee table and department table are classified as U, that is unclassified. Lowest secret class. Okay, lowest class. Then we have subjects, where we have the board of directors, users, and that is accounts head, CEO. In the top secret class, in secret class we have executive body members and CEO, and in confidential class we have manager and directors, and in unclassified we have other normal employees. Okay, according to this LaPadula model, who can read a subject whose class is greater than or equal to the class of the object can read that object. Okay, so if you take some subject that is executive body member, then he can read promotions because the class of executive body member user and promotions table, they are same, and he can read the data from work allotment object because the class of executive body member is greater than the class of work allotment. Similarly, he can read from employee and department. And if he tries to read the data from budget table, he is not allowed because the class of executive body member user is less than the class of the budget table, hence he cannot read. And then if you look at the right operations, the subject's class is less than or equal to the class of object, he is allowed to write. Hence, this user, that is the executive body user, he can write something to budget table because his class is less than that of the budget table. And he can write to promotions because the class of executive body member is same as promotions table, hence he can write. And if he tries to write something to work allotment or employee or department table, it is not allowed because the class of executive body member is greater than the work allotment object or employee or department object, hence it is not allowed. Okay. The next one is role-based access control mechanism. This has emerged as a proven technique for enforcing the security in large-scale enterprise-wide systems. Users are assigned to appropriate roles and permissions are assigned to roles. And roles can be created or destroyed or can be dropped by using the DCL commands like create role and then destroy role. And any SQL implementation as part of its DCL commands, they support these commands. Grant and revoke commands can be used to assign, revoke privileges to roles. That means first we create roles and then we assign the privileges. Okay, and as and when required from a given role, I can revoke a particular privilege. Role-based access control appears to be a viable alternative to discretionary and mandatory access controls. Role hierarchy is a natural way to organize roles to reflect the organization's line of authority and responsibility. Hence, we believe that this becomes a natural fit for today's organizational structures. Then access control policy for e-commerce and the web commerce. What is e-commerce? Any commerce or transactions that are done electronically are categorized as e-commerce. They require elaborate access control policies that go beyond traditional database management systems. The access control mechanisms must be flexible enough to support wide spectrum of heterogeneous objects, because these e-commerce applications, they involve so many objects like credit card information and the third-party authentication and bank accounts and banking records, so many things. Hence, they must be flexible enough to support the wide variety of objects, database objects. And the data that is being exchanged as part of this electronic commerce applications is very, very sensitive. Like we exchange our credit card information, hence it is very, very important to maintain the security. Another requirement is to support for a content-based access control. Of course, it is not totally related to e-commerce, and this can be generalized. Even in other applications also this can be seen. The content-based access control allows one to express access control policies that make the protection object content into account. To achieve this, the access control policies must allow inclusion of conditions on the object content, meaning that a user is allowed to access a given particular object based on the content of the object. Okay, that is very, very important. Next, the requirement is related to heterogeneity of subjects, which requires access control policies based on user characteristics and their qualifications, which we call it as the user profiles. That means the privileges are given depending on the profile of the users based on the educational qualification and characteristics of the users. Considering user profile while defining access policy is one solution to these kind of requirements. Now let us look at the statistical databases and the security in such databases. Statistical databases are used mainly to produce statistics about various populations. For example, demographic data of household and huge population, or the health related records of individuals, and or the income related information or data available. The databases may contain confidential data about the individuals and which should be protected from the user access. However, users are permitted to retrieve the statistical information about the populations such as the average, sum, min, max, count, etc. Let us take an example that the health ministry of the union government, they have a website where they want to share the data about a particular disease or something like that, or a collection of diseases. From such kind of data, statistical data, users cannot access the data pertaining to individuals. That means one cannot retrieve saying that please let me know whether a given person is infected with swine flu in 2014. That kind of queries or should not be allowed. And of course, then what is the use of such statistical data? The users are allowed to retrieve the data on aggregate basis. That means an user can query, give me the total number of persons who are infected with the swine flu virus in 2014, and give me the number of persons who have been taken this kind of vaccine in this 2015, something like that. That means that kind of queries do not reveal the facts about the individuals, rather they are going to reveal the aggregate data. And total 4015 persons have been infected with swine flu virus. That is fine because no individual data is disclosed to the users. The statistical database security techniques must prohibit the retrieval of individual data. This can be achieved by prohibiting queries that retrieve attribute values and then allowing only queries that involve aggregate operations on the data. That means what is the solution to this? When we implement these kind of systems, we should allow only such kind of queries which involve the aggregate operations like average, min, max, count, sum, etc. Such queries are sometimes called as statistical queries. They are safe. They are not going to reveal the data about, they are not going to retrieve or disclose the data of individuals. Okay. And sometimes what happens is, it is possible to infer the values of individual tuples or the persons from a sequence of statistical queries if they are framed intelligently. Let us have a look at this example. Let us assume that in a statistical database we have employee table which has employee ID, employee name, city, age, salary, qualification and department. According to the rule or the understanding, any user can query this database or the table using some aggregate operations. That means get the number of employees who get salary greater than 30,000. That is fine. Get the number of employees whose age is between 30 and 40. That is also okay. But they cannot issue queries like get me the salary of employee 101 who is working with department number 10. That is going to reveal the facts about the individuals. That is the employee ID 101. That should not be allowed. And if that is the situation, let us take an example. If we wish to find the salary of Kiran and we know that his age is 42 and he lives in Pune, we can find this by following sequence of queries. Because it is a statistical database, only the aggregate operations, that means the queries that involve aggregate operations, are allowed. Okay, Let us have a look at this query. Select count star from employee where name is equals to Kiran and age is equals to 42. Will the statistical database system allow this query or not? Yes, it will allow, because it involves an aggregate operation, that is count star. Actually, this says that give me the number where the employee name is Kiran and age is 42. That is fine. And by chance, this is allowed because it involves a aggregate operation, and by chance the result gives me 1. That means it indicates that there is exactly only one employee whose name is Kiran and age is 42. If that is the result of the first query, immediately I can issue the second query in this form. Select average salary from employee where name is equals to Kiran and age is equals to 42. Will this be allowed? Yes, because this involves an aggregate operation, average on the salary, it is allowed. But say because it is intelligently framed and I know how many tuples satisfy this condition, now whatever average salary I get, that pertains to only one employee, and if it is only one employee, the individual salary and then average salary is going to be same. This will give the salary of Kiran. So if someone intelligently frames the queries which involve the aggregate operations, sometimes it is possible to infer the data of individuals from the statistical databases. Hence, proper measures need to be taken to check that kind of queries. That is one important point to be noted. Next is flow control. Flow control regulates the flow of information among accessible objects. That is, if we have two tables, relation 1 and then relation 2, that is flow of data from one relation to the other table, that is R2, is known as flow of information. A flow between object X and object Y occurs when a program reads information from X and then writes it to Y. So when this data can be transferred from relation R1 to R2, when some program reads the data from R1 and then writes it back to R2, then only the transfer of flow of information from relation R1 to R2 can happen. Flow controls check that information contained in some objects does not flow explicitly or implicitly, that means directly or indirectly, into less protected objects. Meaning that let us assume that this object, that is R1, is highly protected, higher classified object, and R2 is less protected. So if the data is available in R1, some subject which is available at this level cannot read this. But if there is a program which reads this confidential data or highly protected data and then writes it to the object R2, then this fellow, the subject who has access to R2, can read that protected data which was actually available and has flown from R1 to R2. And the flow control checks should avoid or prevent this kind of information flow, directly or indirectly. Hence, a user can indirectly get data from Y. So in this case, what happens? Actually, this user, the subject, is not allowed to access the data in R1, but because of this flow from R1 to R2 through some program, he is able to access that protected data directly. A flow policy specifies the channels among which the information is allowed to move or flow. Flow control mechanisms verify that only authorized flows are executed. That means these flow control mechanisms or checks which have been defined at the system level should make sure that the flow occurs only in authorized way. A set of rules must be satisfied to ensure secure information flows among the objects. A covert channel. What is a covert channel? A channel that allows transfer of information that violates the security or the privacy. It allows information to pass from higher classification level to lower classified level through improper means. So then it is known as this channel. In this example, we can consider this channel where the information from R1 is flowing into R2 can be treated as a covert channel, because this allows the users, certain kinds of subjects, to access that protected data when while they were not allowed to access the data when it was residing in the object R1. Okay, and since it has flown to R2, which is less protected, this subject can read or access the data contained in R2. So that flow control checks are very, very essential to check unauthorized, illegal flow of information from one object to other to maintain the security. Next comes the encryption and then public key. All the methods described so far may not be able to protect database from some threats. For example, what happens? So whatever measures we have seen so far, they are able to provide security when the data is sitting in the system, okay, at the database server. Then what happens to the data when it is being communicated or transmitted from one system to the other system through the network? In this situation, we should encrypt the message which is under transmission. Encryption is the means of maintaining the security in an insecure environment, and encryption consists of applying an encryption algorithm using some specified encryption keys. The resulting data is encrypted form in the encrypted form and has to be decrypted at the other end. Otherwise, he will not be able to read the original data. And we have the mechanisms like data encryption standard, DES system developed by US government for use by general public, and the NIST standards introduces the advances in encryption, okay, and the AES and more sophisticated than the DES, and NIST and then AES standards are more sophisticated than the DES, which is used by general public. Then comes the digital signatures, is an example of using encryption techniques to provide authentication services in electronic commerce applications. Like handwritten signatures, a digital signature is a means of associating a mark unique to an individual with a body of the text. A digital signature consists of a string of symbols. There are so many third-party vendors available who can provide this kind of authentication. Okay. Then what are the challenges in database security? Considering the vast growth in volume and then speed of threats to the databases and information assets, research efforts need to be devoted to the following issues. Data quality. That means when multiple users are trying to access the data contained in the database, and when they try to modify the data, and whatever they do, it may be incorrect. So hence appropriate measures need to be taken to check that kind of correctness, okay, incorrect modifications to the database. Database community needs techniques and organizational solutions to assess and attest the quality of the data, and then if they find that it is modified in an illegal way and then which has led to some inconsistency, then the appropriate repair should take place. Then it is intellectual property rights. Watermarking for relational databases have come into picture. That means we know what is watermarking an image. If there is an image, along with the digital image, some pattern is included in the image, so that when someone downloads this image, along with that image, this watermark which is embedded within the image will also be downloaded. And then the owner, it is to prove the ownership of the content. So if somebody says that no, I have not copied this image from you, then by showing that watermark, you can prove that that person has illegally copied that content or the image from your system, which you own. Okay. Similarly, the proving the ownership of the data or the content of the databases has also become popular nowadays. Watermarking for relational data have recently been proposed. This is to protect the content from unauthorized duplication and distribution. That means the users are just allowed to access the data and they are not allowed to copy the data and then distribute it to others. In such cases, what happens is, along with the relational data, you can also embed the watermarks. And if someone illegally copies it or downloads it, then you can prove that that fellow has copied your content by showing this, with the help of these watermarks embedded into the relational databases. And this enables provable ownership of the content. Database, the last point is the database survivability. Database systems are expected to provide services at reduced capabilities despite disruptive events such as information warfare or attacks. That means when an information attack, warfare happens, then the system though it is not working at its full potential, even under those situations, it is expected to provide minimal services. A database management system should prevent an attack and then detect one in the event of occurrence should do the following. That means, and the best thing is to prevent the attacks. Otherwise, detect them appropriately within the that is accordingly, and then take appropriate measures to reduce the damage. What should we do? Confinement. When the damage attack occurs, we should confine the effect of the attack to as minimal portion of the database as possible. Then immediately you assess the damage that has taken place. Then immediately you reconfigure your system and repair the system so that it can immediately made up and then services can be made available to the end users, and make the system that is also provide fault treatment. If you find that some fault has occurred, and then repair it, and then fault treatment should take place, and then the system should be made available for the users. These measures should be taken place in case of attack. The best thing is prevent it. Otherwise, do the following things to minimize the effect of an attack. So in summary, we understood the importance of database security, what are the various threats to the database systems, and what are the various control measures, the role of database administrator in security, and what is discretionary access control mechanism, and what do we mean by mandatory access control mechanism, and what is that statistical database, and how important is the security of such databases, and how one can breach that security by intelligently framing the queries. Okay, and the statistical database system should take appropriate measures to prevent such kind of queries. And what is flow control, what is a covert channel, and how to what check need to be taken by the systems to control this kind of unauthorized flow of information from one object to other object, and what is the role of encryption in database security. And at the end of the session, we discussed what are the various challenges to databases with respect to security. Okay, thank you very much.